students. In this lesson, we're going to learn about another test for inference called the chi-square test. In this first video, we're just going to talk about when the chi-square test is used, and then next we'll learn about how to actually conduct the test within Excel. So we're going to start with a motivating example that will help you to understand what type of data this test applies for, especially since we've learned about many different types of tests for inferential statistics in this course so far. For this example, we're going to look at insurance survey data. It gives the age of customers, if they were male or female, their level of education. It's classified in three ways: whether they're a college graduate, have a graduate degree, or have some college. Their marital status can be married, divorced, widowed, or single. So there's four different options. Then they have their years employed, which is a value, a numeric value, so a metric. Their satisfaction. So that will be on a scale of 1 to 5, where 1 is not very satisfied and 5 is highly satisfied. And then the question, would they be willing to pay a lower premium if they got a higher deductible? And the person had to answer yes or no to that question. So we do have some metrics with numbers as well as some demographic information about these insurance customers. So when we first talked about inference in this course, we talked about two sample tests. So two sample tests are specifically to compare averages when you can put the people or observations into two groups based on some characteristic. So something like the question, are you willing to pay the higher deductible for a lower premium, or the opposite way around, lower premium for a higher deductible? We have the no group and the yes group. If I quickly add filters to this just so I can sort, there we go. We can see that like these are the people who said no to that question. These are the people who said yes. They form two different groups. And for those two groups, we can compare averages. So the averages have to be on numeric data, something like their satisfaction or their years employed, or even their age, something that's actually recorded with a number. We can see if there's differences in the averages between those two groups. Then, once we moved away from two groups, the next type of test we learned is ANOVA, which is used to see if there's differences in averages between more than two groups. So for ANOVA, you have to have at least 3, 4, 5 groups, etc. So for things like premium and deductible and gender, we only have two options in this specific data set, but something like education, if we sort on that variable, there's 3 options: college graduates, graduate degree, and some college. So if you took those as your 3 categories and you wanted to compare averages of a numeric value, like satisfaction, for example, that's where ANOVA would be appropriate. And if you wanted to actually use the ANOVA test in Excel, you'd have to organize your data like this, where you take those 3 categories, and for each of those 3 categories, you put the numeric answer for the quantitative or metric variable, which we gave satisfaction as that example. But the important thing is you have to be able to find averages for the 3 groups. So you're using the categorical question on education, that's demographic information, in order to make the 3 groups, but you still need to be able to find averages for a numerical value. A type of test we haven't discussed yet really leads back to the question of what do you do if you want to look at patterns between 2 categorical variables. So what I mean by that is, what if we have something like gender and education? So for the ANOVA example, we had these educations: college graduate, graduate degree, some college. But now let's say, what if instead of looking at a numeric answer for those 3 groups, what if we wanted to compare genders for those groups? So for graduate degrees, here's the genders, and for some college, here's the genders. The issue here is that we have no numbers. College graduate, graduate degree, and some college are text-based or categorical data. And the gender is also text-based or categorical data. So we cannot find averages in this case. And you need averages if you want to do any kind of t-test. So the paired test, the pooled test, Welch's test, you need to have numeric data that you can find an average for. And with ANOVA, you have more than two groups in that case, 3, 4, 5 groups. But for those groups, you still need to have some kind of numeric data to be able to capture an average of. When you only have two categorical groups, is there some kind of statistical test that can see if there's differences between the counts in each group when you don't have any numbers, when you only have the categorical information? So when you have data that's categorical, really all you can do is count how many times you have each variable occurring. So if you want to count how many times each gender and each college education occurs, how we can do that simply in Excel is by making a pivot table. Pivot tables count frequencies with how many times each of those genders and education levels occur. So if I did want to look for patterns between these two variables that are just categories, I can't find averages, but what I can do is make a simple table that counts how many times those genders and education levels happen. I'm going to click anywhere in my data range and then on the Insert tab, press the Pivot Table button. I'll make sure Excel has the correct range selected, and then I'm just going to place it over here on the side to make sure I have enough space to make the table. The two variables we were talking about were gender and education. I'm going to put one into the columns instead of having both in the rows. And then it doesn't matter which variable you pick, gender or education, drag the other one into the values, and you'll get the table to fill in with the possible counts for each of our gender and education status. We didn't use the marital status variable in this example. I'll copy and paste it just so that you can see it in the same place as the notes. So now that we have this table, because with categorical data, all you can really do, like I said, is cross-tabulate and find the counts so that we know that there's 7 females who are college graduates, 4 females who have some college, and 3 that have graduate degrees. For males, we have 5 that have graduate degrees, they're the highest. Then we have 3 with some college and 2 that are college graduates. And then in the total sections, you can see we have 14 females and 10 males. We have 9 college graduates, 8 graduate degrees, 7 with some college, and we only have 24 people altogether. What we would want to do is develop some kind of test to determine if these counts have any patterns or if they're significantly different from each other. When we talk about being significantly different or not, we do mean a statistically significant difference, which comes down to inferential statistics. And for inferential statistics, we want the probability of an event happening, which means we are looking for a p-value. So the question becomes, how can we do some kind of test where we can get a p-value when we only have counts in a pivot table? We do not have averages like we did for ANOVA or the t-test. So the answer is that we need to use a new type of test that is called the chi-square test. When you first read chi-square test, it does almost look like chi or chai, like the T, but you read it chi. It is a Greek letter, and it looks like this, kind of like a fancy X, is the symbol for chi in the Greek alphabet. And what the chi-squared test is used for is it's specifically for counted data. So what that means is you have to have categorical information that you can capture in some kind of tabular format like this one. Once you have only counted observations in a table like this one, the chi-square test can tell you if this count of the numbers, or what we call the actual distribution, is different from what we call the model distribution. The model distribution usually means that all these groups, all these counts would be the exact same. So basically we're testing if there is a difference in these counts between the different options, like college graduate and female or college graduate and male, or if their counts are close enough that they're about the same. In order to do this test using inferential statistics, we'll follow a 4-step procedure that's very, very similar to all the t-tests and ANOVA tests that we've learned. First, you need to know if the chi-square test is even appropriate for the data. Then once you've established that, you'll write out the hypotheses for the test. You'll check the assumptions and conditions required for the chi-square test. You'll perform the calculations, and finally, you'll make your decision based on a p-value and provide an interpretation in the context of the question. In this lesson, we will learn all the steps for actually conducting a chi-square test, but in this first video, we just want to focus on when you use the test. So for some practice with that, or what we call step 0, identifying when to use the test, I've got 5 different examples. We're going to read through all 5 and then talk about if a chi-square test is the one that should be used or some other type of test. So the first example we have is that a brokerage firm wants to know if the type of account affects the size of the account in dollars. It performs a test to see if the mean size of the account is the same for 3 account types. So chi-squared is used for counted data. That means only categorical information. If you look in this question, it says we're looking at the size of the account in dollars, and we want to find the mean or average size of the account. When you're dealing with quantitative data like dollars and calculating means, that's either going to be a t-test if you have 2 groups or an ANOVA if you have 3 groups. This one clearly says we want to see if there's a difference in the mean size of the accounts for 3 different account types. The 3 different account types would mean 3 groups. So this would not be a chi-square, it would actually be an ANOVA because we have 3 groups and a quantitative variable to average with the mean. We're going to find the mean account size in dollars. So when you have quantitative data in 3 groups, an ANOVA would be the one to use. The next question says, is the quality of a car affected by what day it was built? A car manufacturer examines a random sample of warranty claims filed over the past 2 years to test whether defects are randomly distributed across days of the work week. So essentially, in this one, if we're looking at days of the work week, we'd have like Monday, Tuesday, Wednesday, Thursday, Friday. And then it says they want to basically count up the warranty claims based on what day of the week the car was built. So maybe of their warranty claims, like 34 of the cars were built on Monday, 56 on Tuesday, 40 on Wednesday, 45 on Thursday, and let's say 51 on Friday. In this case, we are trying to see if these counts differ significantly, or would they be about the same for every day of the work week? In this case, because all you're doing is counting up defects across days of the week, this does involve 2 different categorical variables. Basically, defect or not, it gets counted, and day of the work week, Monday, Tuesday, Wednesday, Thursday, Friday, gets counted. So this one does only deal with counted data, and this would be where you would apply a chi-square test. There's no average here. We're not talking about the price of repairs. We're just talking about whether it has a defect and what day of the week it was built on, both of which are categories that we can only count how many times they happen. Question number 3 says, an academic research office at a large community college wants to see whether the distribution of courses chosen is different for residential and non-residential students. It assembles last semester's data and performs a test. So basically, this one would be like residents, non-residents, and then they'd look at the courses, humanities, social science, or sciences. And if they just want to see how many students take each course, like maybe 100 residents take humanities, 45 non-residents. Maybe for social sciences, it's like 65, 45. Maybe for sciences, it's like 30 to 80. The important thing here is the types of courses, humanities, social sciences, and sciences, and if the student is a resident or not, are both categorical variables, When you have two categorical variables, all you can do is count how many times each one occurs. These are counts, so this would be the chi-square test. Another example of a chi-square test. Number 4 says company policy calls for parking spaces to be assigned to everyone at random, but you suspect that might not be so. There are 3 lots of equal size, lot A, which is right next to the building, lot B a bit farther, and lot C on the other side of the highway. You gather data about employees at middle management level and above to see how many were assigned in each parking lot. So basically you'd have like A, B, C, the 3 parking lots, and then you look at the management level, like middle, senior, executive, I don't know all the titles, it doesn't specify, it just says middle management and above. And you'd count how many spaces or how many people got in each one. So maybe there's like 10 in lot A, 15 in B, 17 in C, etc., etc. Here I am making up the numbers. It doesn't really matter what the numbers are. What matters is that based on the parking lot A, B, or C, and based on the management level, middle and higher, those are categories that you put people into. They don't have a number associated with them. It's something that's measured, something that's quantitative. All we can do is count how many people fall in each category, and that is when you use the chi-square test. So that's another application of our chi-square test. Finally, number 5, we have a researcher for the Booksellers Association wants to know if retail sales per square meter are related to serving coffee or snacks on the premises. She examines a database of 1,000 independently owned bookstores to test whether retail sales are related to whether or not the store has a coffee bar. So in this one, it looks like they're looking at retail sales, dollars per square foot, and they're forming 2 groups. Does the store have a coffee bar or not? Yes or no. What makes this question different than the previous one is retail sales, again, is in dollars per square foot. That is something quantitative. So if the store has a coffee bar, yes or no, that is 2 groups. But if we're looking at the retail sales in dollars per square foot, that would be some kind of dollar amount that's quantitative that we could find an average for the different stores of that type according to the groups. So as soon as we have this quantitative variable that's involved that we have to analyze, this is some other type of test. And in this case, because it's only whether a store has a coffee bar or not, that's 2 groups. So it's some kind of 2 sample t-test. We don't have enough data here to know if it would be pooled, paired, Welch's, but we do know it's some kind of 2 sample t-test. If you have 2 groups, yes and no, and you're looking at the average retail sales, when we're dealing with averages or means of quantitative values, that is when you would apply a 2 sample t-test. So in this example, we had 3 that did lead to chi-square tests when you only have values you count based on categories. And we had 2 that either led to a ANOVA or a 2 sample t-test when you have quantitative measured values that you want to compare averages for. So just keep in mind when we use the chi-square test is when we have counted data that can be captured in a table and we want to see if the actual distribution of values is different than what you would expect, which is usually that you have equal amounts in every single count for the cross tabulation. Please proceed to the next video and I'll show you how we can conduct the chi-square test in Microsoft Excel.